Good morning, ladies and gentlemen. I'd like to thank the Steel Construction Centre for looking after me. They've looked after me very well so far. I have been shown the famous places in Kiev. I've seen the famous squares, I've seen the famous monuments, and I've seen McDonald's. So I feel very familiar with your city. I would like to recommend this excellent publication to you. Really good, I think, and from time to time, on occasions, we might look in this book, but I think this is an excellent publication, and I hope you enjoy that. I have 3 objectives, really, over these 2 days. My first objective is, of course, to tell you about the Eurocodes. And more than anything else, I would remind you that the physics has not changed. So a piece of steel does not know whether it's in Ukraine, or in France, or in Great Britain, or anywhere else. So the physics has not changed. The structural mechanics has not changed. So I am confident that when you look in the Eurocodes, you will recognize the clauses. There will always be some expression which is going to be used to check some structural behaviour, and you will be familiar with the structural behaviour. The issue will be, perhaps in the Eurocodes, it may be presented in a different way. The issue will be that there are different names and there are different symbols. But more than anything else, remember that the physics has not changed. So that would be my first objective. My second objective is to make you concerned about the national annex, because you will always need to refer to the national annex, and I will have much more to say about that over the next 2 days. And my final objective is just to entertain you for 2 days, because you could go fishing, or you could go out in the country, or you could practice structural design, and yet you are here with me for 2 days. Okay. I thought I would tell you just a little bit about myself, and then about the Steel Construction Institute, and then give you an introduction to the Eurocodes. So I started my career working for the National Railway Organisation in the UK. I designed a number of things, and then I spent 3 years on site working on bridges. And after I worked on bridges for 3 years, I then looked after tunnels for a little while. And then I met a man on a train, and he said he knew of a steelwork fabricator, and they wanted a design engineer. And the steelwork fabricator was in a very horrible part of the United Kingdom. And I said, there is no way that I'm going to work in the steel industry, and there is no way that I'm going to work in this horrible part of the United Kingdom. But then I thought, perhaps I'm being too hasty, so I went for the interview. And when the managing director said, how much do you earn? I increased my salary, and he offered me even more. And then he said that we also give you a company car. And then he said, we also give you free petrol. So I left the railway and I joined a steel fabricator. It was a very small company, and there was only me, so I did all the design. All the structural design, all the connection design. And then after 3 years, I was promoted to be their technical director, but there was still only me. So I did all the design, I did all the connection design. I did get a larger car. Then I went to work for a very large steelwork fabricator, and all day and every day I designed connections. And I thought, do I want to spend the next 30 years designing steel connections? and the opportunity came for me to join the Steel Construction Institute. So that's where I work now. These are my responsibilities, so I'm always involved with connections. I am responsible for frame design, particularly portal frames for industrial structures, multi-story frames. I look after the advisory service, so we have members and they telephone us or they send us emails and we respond to their questions. I do quite a lot of work on design standards, so I sit on a number of committees where we discuss the design standards, and you can imagine that most of the committee work is concerning the Eurocodes at this moment in time. And finally, I do a lot of courses in the UK. I have to say this is the first time ever that I have lectured to a lot of people wearing headphones. I have no idea whether you're understanding what I'm saying. I hope you are. So this is the Steel Construction Institute. There are about 30 people who work at the Steel Construction Institute. We have a mission to develop and promote the proper and effective use of steel in construction. So we write design guides, we train people, we answer their questions. We are an independent company, so we are not for profit. We don't try and make a profit, but we very definitely try and avoid a loss. We have around 600 members, and most of our members would be design engineers or steelwork fabricators. And I think most people join us because of the publications that they receive, but also because of the advisory service. So when people have problems or when they have questions, then we will help them out. And people find that very valuable, because if you can avoid a problem, then usually you might avoid a very expensive mistake later on. And we have lots and lots of publications, so around about 300 publications. Our best-selling book is what we call, for obvious reasons, the Blue Book. And the Blue Book is really boring. It's approximately 300 pages, and it contains numbers, and even more numbers. So these are lookup tables of member resistances, which is easy for us because, of course, we're using rolled sections, so we are using standard sections. It's also our most expensive publication, and many people in the UK would have this particular publication. And I feel slightly sorry for them because it's a really boring book. We also do books on connections. So here is a picture of one of our green books. So nominally pinned connections in this case, end plates or thin plates. And these would be used by practicing engineers, and these would be used by steelwork fabricators. We also do a lot of project work for different clients. So we write software. We might help manufacturers develop a new product, and we add a quality mark to some products. These are some more areas where we work. So fire engineering, and I know that fire engineering is important in the Ukraine. Composite construction, so composite floors, would be the standard solution in the United Kingdom. So a lot of our work is to do with composite floors. We don't do much on bridge construction because there are not many new bridges in the UK. The UK is a small country. We don't have many new railways, we don't have many new major roads. We deal a lot with explosions, and that would concern explosions really on offshore oil production platforms. that's a real hazard in that sort of environment. We do a lot with light gauge steelwork. So light gauge steelwork would be 1 millimetre or 2 millimetres thick. It is very much a growing area in the United Kingdom. So maybe panels, as you see here, or maybe complete structures. And we do a fair amount in sustainability, so thermal performance, carbon, acoustics, those sorts of issues. So that's the SCI. Here then we're moving on to my technical area today, so a little bit of background on the Eurocodes. So the Eurocodes then, the ambition was to have a set of design standards which could be used across Europe, across the entirety of Europe. And in the UK there has been a lot of resistance to the Eurocodes, because in the UK people would prefer to continue to design to their own standard. And they will ask me, what is the advantage of designing to the Eurocodes? Are steel structures lighter? But the answer is that the Eurocodes were not developed in order to improve the technology. They were a political development so that one could trade entirely across Europe. I think that there are some improvements in technology, and I will try and demonstrate those to you later on. One problem with the Eurocodes is that there are so many documents. So here is a slide which a European colleague put together, and you'll see down at the bottom here 5,200 pages, which is huge. In the steel world, you will notice that the steel parts, EN 1993, they are the largest contribution to the Eurocodes, with nearly 1,500 pages. So if you wanted all the Eurocodes, this is a large number of documents, and I would imagine that it will be expensive. That's one of the problems that we face in the United Kingdom. The second issue is that these pages, they are before you've got the national annex. So in addition to the Eurocode, every one of these parts, and you'll see that there are 58 identified there, they will all have a national annex. Why do we need a national annex? Well, because the goal of a common design standard across the whole of Europe was not achieved. The problem is, of course, that people in the United Kingdom, we think that we know steel design. And we think that we know steel design better than anybody else in the whole world. Unfortunately, people from Germany, they think they know steel design as well. They are wrong, of course. But then, when there is a difference of opinion, what do? You debate and debate for 30 years. And then you must decide, perhaps we leave this issue out altogether, and we say nothing about it in the Eurocode. Or perhaps in the Eurocode we make it a matter for national decision. And if it is a matter for national decision, then it will be part of the national annex. So the national annex is really, really important, because it contains the things which a country feels very, very strongly about. So if you do not pay attention to the national annex, you are in serious danger of making a huge mistake. I will try and emphasize that again a little bit later on. In theory, the national annex is always to be made available in the language of the country and in theory it's to be made available in English. So you are supposed to be able to get the national annex for any particular country at least in English. I don't think that has been achieved throughout Europe. You need to be aware of the national annex for the country where the structure is going to be built. So, for example, there would be nothing to stop you in the Ukraine designing a structure to be built in the United Kingdom or to be built in France. But if it was going to be built in the UK, you would need the UK national annex. So where the structure is to be built, not where you're designing. So if you design to the Eurocodes, but in different countries, certainly a different structure will be the result. Because some people feel very, very strongly about certain issues in the Eurocodes. So this little chart, you'll see on the top right as you look, it actually concerns the concrete code. So this is not the steel code, this is the concrete code. But it gives you an idea of how some countries adopt the recommended values and how some countries change rather a lot. So on this particular chart, the green on the left-hand side, that represents where countries have accepted the recommended values in the Eurocodes. And if it's red, it means that a country has changed the recommended values. So the more red that you see, the more changes there are in the national annex. So maybe not so much of a surprise, the bottom row there is Germany. So Germany have changed an awful lot because they feel they know about steel construction. They are wrong, of course. The United Kingdom is here, so we think we know about steel construction. I think this is Lithuania, and they seem to have accepted most of the recommended values. So it does change from country to country. I received from the Steel Construction Centre here, I received some of the Ukrainian national annexes. So I've had a look through the Ukrainian national annexes. And in many places, it would appear that your national annex accepts the recommended values. In some places, there are differences, and we'll look at some of those later on. But in many cases, important factors in the Eurocodes, in the Ukraine national annex, they are accepted. So there are some examples. That's how much of the Ukrainian national annex looks. The recommendations are accepted. Now, I don't wish to talk too much about the situation in the United Kingdom, and I will try and limit myself to situations where examples will help. In the United Kingdom, we are governed by something called the building regulations. And the building regulations in the United Kingdom, they do refer to the Eurocodes. But the regulations make it clear that design to the Eurocodes is only one way to satisfy the regulations. In the United Kingdom, we could use the Spanish design standard. We could use the German design standard. We could use no design standard at all. So there is no obligation to actually design to the Eurocodes. We do have a problem because our previous national standards were withdrawn 4 years ago now, so they are no longer available in the United Kingdom, and yet many people in the United Kingdom still use the previous national standards because they are allowed to under our building regulations. And I think that will continue for many, many years. One contribution to the Eurocodes is something called CE marking. So CE marking is a quality stamp, effectively. Materials must be CE marked, and fabricated steelwork must be CE marked. So anything which is placed on the market in Europe must be CE marked. So plate and sections that are provided by manufacturers will be CE marked, and certainly from summer of this year, fabricated steelwork must be CE marked. CE marking is covered by European Standard 1090, and one of the options within that standard is that you can declare a design resistance. And that means that you will be saying a piece of steel is capable of carrying a certain number of kilonewtons. If you do declare a design resistance, then 1090 is recommending that you calculate that resistance in accordance with the Eurocodes. So that means that if anybody is interested in CE marking, they will also be interested in design to the Eurocodes. Part 2 of that standard covers things like tolerances, workmanship. So in the UK then, design to the Eurocodes is becoming more common. I think about 40% of designs in the UK will now be to the Eurocodes. Most of the larger steel designers, so the large design practices, a famous name is Arup, an international practice, they will be designing to the Eurocodes. Many of the smaller practices, they will still continue with the previous national standards. I think the change is happening because our national standards have been withdrawn. I think it's encouraged by CE marking. I think it's encouraged because there is the option of a wider market. So in the UK, we could design buildings to be constructed in France or Germany or somewhere else in Europe. Perhaps people are adopting the Eurocodes because of the advantages. So even though it was a political decision, I do think there are some advantages in designing to the Eurocodes. So this may not be the same in the Ukraine, but in the United Kingdom, we would be designing for lower loads, and therefore we could produce a more economical steel structure. And not only would we enjoy lower loads, we would also enjoy increased resistances. So the two, lower loads and increased resistances, make the Eurocodes very attractive for us in the UK. Okay, let's move now to our technical subject, really, steel design. So a little bit of background. This is a demonstration of the Eurocode structure. We have characteristic actions. I would have called those, in the UK, I would have called those loads. But the Eurocode term is actions. And they will come from somewhere in the 1991 suite of Eurocodes. There are a number of Eurocodes that all begin 1991. They cover things like snow and wind and loads on floors. But notice, most importantly, you cannot look at these Eurocodes without the national annex, because the national annex is likely to change values, is likely to give you wind loads, for example, in your country. So you definitely need to look at the national annex. And then entirely separate to the entirely separate to the actions is the resistance. And for the next 2 days, we will be looking at Eurocode 3, or Eurocode 1993. But notice again, really importantly, we will always need to be looking at the national annex, because that will change country by country. And then those are brought together by a Eurocode called EN 1990. And again, it involves the national annex. And your national annex has things to say about the content of EN 1990. So over on the left-hand side, a characteristic action will be typically something that happens once every 50 years. But when we compare that with a resistance, we want a factored action, or maybe you would know it as an ultimate load. So we need to combine the actions to create ultimate loads. And we find in Eurocode 1990, we find the factors that we apply to the characteristic actions. So 1990 is going to be a really important code for us, because it takes characteristic actions and then allows us to compare with our calculated resistance. So here is 1991 and 4 parts. We will be interested in 1991 subpart 1, but then 1991 subpart 1 splits itself into all these different subparts again, and each one of these will have a national annex. These are the parts of 1991 that I think you will need most often. So the ones in the bold type, I think, are the ones that you would use most of the time. 1991-1-1, that's the top line. That will cover things like imposed loads on floors. It will cover things like imposed loads on roofs. So for sure we will need that. For sure we will need 1991-1-3, which covers snow. For sure we will need 1991-1-4, which covers wind. And I think you will need 1991-1-7. That covers accidental actions, but I would know that as robustness, or I would know it as the avoidance of disproportionate collapse, or I would know it as tying. And I can see that one gentleman is content with that. I hope everybody else is. Here is the full range of the Eurocodes. Today, of course, we are interested in 1993. So then 1993 splits into a number of parts, and here they are. The general objective of the Eurocodes is that repetition is avoided. So the most important part for us will be part 1, generic rules and rules for buildings. If you were interested, for example, in a silo, you would need part 4, but part 4 will only tell you the rules which are very specific to silos. It will continue to refer you back to 1993 part 1. So if you're designing a bridge, you would need part 2. But those parts tend to be thinner, have less content, because the bulk of the content will be in 1993 part 1. But then 1993 part 1 splits into 12 different subparts. And maybe I am emphasizing this too much, but each one of these subparts has a national annex. So the number of documents and the cost of these documents is increasing quite a lot. Some of these perhaps you will not be very interested in, because not many people do shells, for example. Maybe not many people do stainless steel. Maybe not many people use very, very high strength steel. But some of them you will certainly need. The ones which I think you will need most of the time are these 4. So 1993-1-1, and that will be the core document that we will be working with really, certainly today, and for much of tomorrow as well. 1993-1-5 is described as plated elements, and you would perhaps think that would cover plate girders. Would that be a term that you would recognise, plate girders? I hope it's a term that you would recognise. So if you are fabricating a very large girder out of 3 plates, that's what I would describe as a plate girder. They would tend to be used in bridges rather than buildings. The reason why, therefore, I put this document as a recommended document is that if you are checking a small section for a concentrated load, so if we have a column perhaps and a beam coming in here, we would worry about the resistance of the web in crushing or in buckling. Are you happy with that? I shall draw something. So this might be a column in a building, and this might be a beam which has been welded to the column. And maybe there is a bending moment on this beam. And therefore we know that there is a very large compression in the bottom flank. And we are concerned about the web of the column, because maybe it will crush locally, or maybe it will buckle between the 2 flanges. So in design standards, there is always a check to see whether you need to put a strengthener at that location. Does that make sense? Excellent. I can see a number of people nodding, which is good. You could be listening to the radio as far as I know. So, although we are not really covering bridge girders today, that's why we would be interested in plated elements so that we can check the resistance of a web. We will be looking at this one, joints, or I would describe those as connections, and we will be looking at 1993-110 because that covers the important choice of a steel subgrade. So as designers, you should not just be interested in the strength of steel, you must be interested in the subgrade as well. This is quite a key issue in the UK because many steel designers who work for design practices, they do not specify the steel subgrade. And therefore, if I was working for a steelwork fabricator, I would give them the cheapest possible steel I can find. That may not be adequate in some circumstances, so we will look later on at this choice of steel subgrade. So problems, ladies and gentlemen, because even if you limit yourselves to just a small number of standards, there are a lot of documents that you need. You also need the National Annex, so many, many documents, and I guess that will cost you. Sometimes even the combination of the Eurocode and the National Annex does not tell you everything that you need to know. Because in some countries they feel that certain values, they feel that your undergraduate education should teach you how to calculate those things. They consider them to be basic values, and therefore they think there is no need to provide them in the Eurocode. In some countries, for example Great Britain, we have no idea what they are talking about. So it's not in the Eurocode, not in the National Annex, so you need to refer to what's known as non-contradictory complementary information. That is a Eurocode term, NCCI, and that would be advice and that would be helpful information to cover the things that the Eurocode or the National Annex does not tell you. So the sort of advice that you get in good documents like this, you would consider to be NCCI. When there are things you don't know or when the Eurocode is silent on something, for example, I look in the back of this publication, I'm on page 94 and 95, and it tells me about effective lengths of beams. Well, the Eurocode doesn't say anything about effective lengths. So if you're interested in effective lengths, for example, you would look on those pages. In the UK, we have a website which captures lots of NCCI. I look after the website, but this particular site, it's free for everybody to use, by the way. It contains lots of helpful guidance that people will need if they are designing to the Eurocodes. Now you think, perhaps, ladies and gentlemen, that the Eurocodes are rather new to you. Unfortunately, already the Eurocodes are being revised. So they hope to have revised Eurocodes available in 2019 or 2020. So already there is significant work going on in changing the Eurocodes. So finally from me then, this course today. It's different for me because I come from a country where a multi-storey frame, 70% of multi-storey frames will be steel. They will all have composite floor construction. If it were an industrial structure, 98% would be steel. So steel is the standard solution, if you like, in the United Kingdom. And of course, in the United Kingdom, we use rolled sections all the time, universal beams and universal columns. So I've tried to change the material within this course to suit what happens in the Ukraine. So I've tried where I can to follow the National Annex, and I will try and point out some of the contents of the National Annex. And the examples that we will be using today and tomorrow, they are all members fabricated from plate, because I understand that here in the Ukraine, you tend to fabricate your beams and your columns from 3 plates, rather than use rolled sections. And the basic grade that my examples follow today will be S235. So, as I continue now, I think I have to assume that you're not familiar with the Eurocodes. I know 1 or 2 people in the audience may well be very familiar with the Eurocodes. I know there are some people who probably were involved with writing the National Annex, and I know there's at least 1 person who reviewed this document. So there will be some people who know the Eurocodes very well indeed. If you are familiar with the Eurocodes, I apologise in advance because I will be telling you things that you know. So what are we going to do? We're going to do some lectures. I have some numerical examples for you to complete, so I hope you've brought your calculators. You will get a complete answer at the end of today and at the end of tomorrow. So if you don't manage to work your way through the numerical examples, you will have a completed worked example to take home. And finally, I hope you ask me questions. I know that's going to be difficult, because unless you ask in English, it will be via the translator, so that will be a problem. Maybe I will have to ask you to come and draw things so that I can understand your question. But please feel free to ask me questions. I don't know whether this makes any sense, does it? I use Google Translate to get this. My view is that if you ask me a question, then if it's easy, I will try and answer it. If it's difficult, I will pretend that I don't understand the question.